Next we will see the network theorems, how we apply them in AC circuits. Okay, so first one is superposition. So this theorem is particularly useful because of one unique application. Okay, so what is that application? It can be used when there are sources of different frequencies. Okay, so that means in the same circuit, let us say you have sources, two different sources, and both of them have different frequencies. Then can we apply the phasor analysis? We cannot apply. We've already discussed why we cannot apply, right? So but if you have superposition, then you can take each of the sources and you can do the phasor analysis, and then finally you can add the individual responses. And the one thing that you have to remember when you are adding the individual responses is that you should add them in time domain. Okay, so remember, note, individual responses should be added in time domain, not in the phasor domain. Okay, so we'll do a question here. Find I naught using superposition. So here the circuit is given, I naught is the current through 8 ohms. So you can pause the video and you can first try it out for yourself. So how many sources are here? You can see that there is a current source and a voltage source. So we will see the effect of each of the sources. First we will take the current source. So in that case, what will happen to the voltage source? It will be short circuited. So you can redraw the circuit here. 10 angle 0 degrees ampere current source only. Okay, so what will you get here? Rest of the circuit will remain as it is. Only the voltage source will be short circuited. Okay, so now this current we will take as I naught 1 to differentiate with the actual current. So here you can see that this is one resistance, this is an impedance, and this is a capacitor and resistance. All of these three branches, they are parallel to the current source. Okay, so we will redraw it in a slightly different manner so that it will become more clear to you. There are three parallel paths. So three impedances, and the current source is like this in parallel to all of the impedances. This is 6 ohms, this is J4, this is minus J2, 8 ohm, and what current we want? IO1. So this we can easily find using current division, right? So using current division rule, we can write I naught 1 is equal to, we have to take the reciprocal of the impedance, right? So 1 divided by 8 minus J2 divided by the sum of reciprocals. So 1 by 8 minus J2 plus 1 by J4 plus 1 by 6 into total current. So if you can convert these into the magnitude form, then it will be easier to solve because here you have division. So the final answer I am going to write, you will get 3.37 angle 51.85 degrees. Next we will take the voltage source only. Okay, so that means only this source. So then what will happen to this current source? It will be turned off. That means it will behave like an open circuit. Okay, so you can redraw the circuit here. The effect of voltage source only. So this is going to be capacitor and resistor will be like this. This is the inductor, resistor, and here you have the voltage source. Current source is open circuited. So this is the current we want. IO2 we will take. So this is what 8 ohm. This is minus J2 ohms, 6 ohms, and this is J4 ohms. And this is 50 angle 30 degrees. Okay. So first you can find out the total current that is coming out of the source. So how will you find that? I is equal to 50 angle 30 degrees divided by 6 ohms in series with the this and this, they are in parallel. Okay, so J4 in parallel with 8 minus J2. So here you will get some value of I. Then what will be I naught 2? This you can again get from current division. Since you have only two branches here, how you can write IO2 you can take as the other resistor, other branch resistance or impedance divided by the sum of all of the impedances. So 8 minus J2 plus J4 into the total current. Okay. So this final answer you're going to get 2.81 angle 81.85 degrees. Okay. So finally you're going to get the total current I0 will be the sum of the phasors. So you can write phasors all over. Okay. So this is the correct representation. Okay. So I01 plus I02. Okay. So I01 we got as 3.37 angle 51.85 degrees plus 2.81 angle 81.85 degrees. Okay. So this final answer you're going to get 5.93 angle 65.6 degrees. Next we will see the Thevenin's theorem. So we will understand by means of an example. Find Thevenin's equivalent across AB terminals. So this is the given circuit. Here A and B terminals are present. Here you can see that there is a dependent source also present. So what should we do with dependent source when we are finding the Thevenin's resistance? We cannot do anything. We cannot turn it off. Okay. So first we will start with the Thevenin's equivalent voltage. Finding VTH. So how to find VTH? We just have to find out the voltage across the A and B terminals. Okay. So this is the voltage VTH that we need to find. Okay. So now if you see at this node, if we apply the KVL. Okay. So applying KVL at KCL at node 1. What will you get? You can see that 15 angle 0 is entering. I0 is leaving. And this 0.5 I0 is leaving here. Okay. So since this is open circuit, the current through this also will be 0.5 I0. Okay. So what will you get here? 15 angle 0 degrees is equal to I0 plus 0.5 I0. So this means that I0 is equal to 10 angle 0 degrees. Now how to find out VTH from here? Okay. So you can see that through the current source we cannot find. Okay. So the only way to find is we can apply KVL here. You can see that along this loop, if you apply KVL, then what is the voltage here? This is VTH. We know the current through this. We know the current through this as well, right? I0, this current is I0 and here current is in the opposite direction, 0.5 I0. Okay. So applying KVL, we get minus VTH minus, here it will be minus because we are going in this direction, current is flowing in this direction. Okay. Minus 0.5 I0 4 plus J3 plus I0 2 minus J4. This is equal to 0. Okay. So from here you can find out VTH is equal to I0 2 minus J4 minus 2 minus J 1.5. Okay. So you know I0 here. So you can find the final value is going to be minus J 55. Okay. So we have found the Thevenin's voltage. The next step is to find out the Thevenin's resistance. Finding ZTH. Okay. Because we are dealing with impedance here, not just resistance. Okay. So this is the circuit. What is the first step? We have to turn off the independent sources. So there is an independent current source which should be open circuited. Okay. And what about the dependent source? It should be left as it is. But when there is a dependent source, we have to make use of a current source or a voltage source. We will take a current source. What will be the magnitude? We want a 1 ampere current source. Okay. So this is for easier calculation. So now if you can find out the voltage at this terminal, then you can get the Thevenin's resistance. So if you apply KVL at this node, you can see that 1 ampere is flowing into the node and 0.5 I0 and I0 are flowing out of the node. Okay. So since this is a phasor, you can write here as 1 angle 0 degrees. Okay. So what will be the KCL? gives 1 angle 0 is equal to 0.5 I naught plus I naught. So I naught you're going to get 2 by 3 angle 0 degrees. Now what will be VA? Here also in a similar manner you have to find out if you apply KVL across this loop. Okay. So what will be the voltage here is V and we are applying KVL here. So then what will you get? Minus VA plus because the current is flowing in the direction that we are going. Okay. So all of these circuit elements I naught is only flowing. Okay. So you have I naught into sum of all of the impedances. So what will that be? J3 plus 4 plus 2 minus J4. So this is equal to 0. So we know I naught here. So we can find out VA. Okay. So the final answer I am writing VA you are going to get as 4 minus 2 by 3 J. So this will be the impedance, Thevenin's impedance. Therefore ZTH is equal to VA by 1 angle 0 degrees, which is equal to 4 minus 2 by 3 J. So you can write it in terms of magnitude and phasor as well. Okay. So what will be the Thevenin's equivalent? Thevenin's equivalent is going to be a voltage source which is having a magnitude VTH and this is ZTH. This we found as 4 minus J 2 by 3 and VTH we found as minus J55 and this terminals will be A and B.